Hello, this is Lab 11, phase shift in a LRC circuit. So an LRC circuit is just a circuit with a resistor, capacitor, and inductor with an AC current source. So what we mean by phase shift is if we have a sine wave going through our circuit, each component might react differently, or it might lag behind, or it might be ahead of the current source. So in this, I have a two waveform example. I have the solid line, and I have a dashed line. And for a phase shift, this is an example of a 90-degree phase shift. So it's just completely offset from another, and we can measure this. And the way we measure this is, in this one, we pick a reference point. So for example, in our circuit, this might be the voltage source. This might be the voltage on the resistor. And what we do is we pick some common reference point, in this case, the peak of both, and we look where they align on the time axis. And the difference of where the two meet is our phase shift. So we can use the software, which in another video I'll show you the software. We can look at the phase shift, and we look at the phase shift at resonance, above and below resonance. So we know from a previous lab that the resonant frequency is 1 over the square root of the inductor value times the capacitor value. And we know that the inductor is directly proportional to the frequency, whereas the capacitor is inversely proportional to the frequency. So that will affect the phase shift of our inductor and capacitor respectively at above and below resonance. So in general, what we can expect is that at resonance, the source voltage is going to be approximately equal to the voltage on the resistor. And let's see, below the resistance, it's definitely not going to be the same. That's also true for above resonance. The source voltage is not going to be the same as the voltage on the resistor. Important to note that you'll be asked this in the book, but things to note is that above resonance, because the inductor is directly proportional, the inductor will dominate. And the opposite is true below resonance. Below resonance, the capacitor will dominate because it's inversely proportional to the frequency. What I'm not showing here, which we'll be showing in the other video, is that in reality you'll be looking at, rather than the two I have displayed here, there will be 4 waveforms. One for the resistor, inductor, capacitor, and the source. And it'll be much easier to show with the software. So we'll go to that next.